Hi, Algebra 2. This is the homework answers for lesson 4. So if we're looking at question 1 says I have point P. P is the point 0.6 comma negative 0.8. Now remember, when I have a point xy, the x coordinate is the cosine and the y coordinate is the sine. And that's when the point obviously is on the unit circle. They want to know what is the value of sine theta, cosine theta, and tangent theta. So sine of theta and cosine of theta are easy because, again, sine is just the y-coordinate, so that's negative 0.8, and cosine is the x-coordinate, and that is 0.6. Now remember, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So tangent is really sine over cosine. So negative 0.8 over 0.6 is negative 4/3. Another way to do this is if I was using the Pythagorean theorem, I just wanted to show you this, how it would look on a graph of 0.6 and negative 0.8, and there is that point. Okay, and then the way that's set up right here, if I want to do the tangent of theta, tangent is opposite over adjacent. So there's that negative 0.8 over 0.6 again. So that's another way to find that tangent. Question 2, I have the unit circle, circle O. So that obviously has a radius of 1 right here. It says OB equals 1. Which line segment is equivalent to the sine of theta? Remember the point xy, y is the sine. So y is this AB right here. So question 2 is choice 1. Question 3, sine of theta is greater than 0. That happens right in quadrants 1 and quadrants 2, right? Sine is positive. It's all students take calc. So in quadrant 1, everything's positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. In quadrant 4, cosine is positive. So sine is greater than 0, meaning it's positive in quadrants 1 and 2. Tangent is less than 0. That means it is negative. Tangent is negative in quadrants 2 and quadrants 4. So therefore, where is this both happening? What do they have in common? Quadrant 2. So in quadrant 2, sine is greater than 0 and tangent is less than 0. Number 4, if the tangent of an angle is negative and its cosine is positive, in which quadrant does the angle terminate? So this is just like question 3. So in quadrant 1, cosine is positive, and in quadrant 4, cosine is positive, because that's all students take calc. C stands for cosine being positive, and the tangent is negative. So tangent is negative. Tangent is positive in quadrant 1 and quadrant 3. So tangent is negative in quadrant 2, and it's negative in quadrant 4. So quadrant 4 is the answer because in quadrant 4, cosine is positive and tangent is negative. Question 5, which function is positive for angles terminating in quadrant 2? In quadrant 2, sine is positive. All students take calc. All of them are positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. And cosine is positive in quadrant 4. Question 6, which of the following is not equal to 270, sine of 270 degrees? Sorry about that. So I drew this right here. So this point right here is 1, 0. This point right here is 0, 1. This point right here is negative 1, 0. And this point right here is 0, negative 1. So the sine of 270, this is the sine of 270 right here. Because remember, x is the cosine and y is the sine. So the sine of 270 is negative 1 because this point right here is an angle of 270 degrees, right? This is 0, 90, 180, 270, 360. So the sine of 270 is negative 1. And then I did the cosine of 180. The cosine of 180 is right here. Cosine of 180 is negative 1. The negative cosine of 0, so cosine of 0 is right here at 1, but it's the negative cosine, so I'm going to negate that. That would be negative 1. and the negative sign of 90. So sine of 90 is right here. Sine of 90 is 1 because this is the sine of 90. The sign is the y, and that's going to be negative. And the one, the answer is going to be choice 4 right here, the sine of 360. So the sine of 360, let me just write that in. The sine of 360 is going to be my answer. The sine of 360 is right here, and that is going to be equal to 0. All right, next page. Number 7, they want me to find the exact value of each of these. So again, I drew that little graph. This point is 1, 0, this point is 0, 1, this point is negative 1, 0, and this point is 0, negative 1. I can also use a calculator for this, but the cosine of 90, so this is 90 right here where my pen is. Cosine is the x coordinate, so it's 0. Sine of 180, this is point is 180 right here. Sine is the y coordinate, so it's 0. Tangent of 540, so I have to do 540 minus 360 is really just the tangent of 180. Here's 180 right here, and tangent is sine over cosine, and that equals 0 over negative 1, which equals 0. And sine of negative 810, so I am subtracting 360, and that's really the same thing as negative 90. Negative 90 is right here at 270, right? Going 270 positive is the same as going negative 90 in the clockwise direction. So this right here is the sine of negative 810, and the sine is the y coordinate. Okay, and I put this over here just for you guys all to remember. XY is the point, cosine is x, sine is y, and tangent is just sine over cosine. Number 8, there are other points on the unit circle besides the ones that we determined in this lesson. Every point, though, must satisfy the equation x squared plus y squared equals 1. Find all possible values for the x coordinate if y equals negative 5 over 13. So all I'm doing is plugging in negative 5 over 13 for y. I'm squaring that. It is a negative, but it's being squared, so it's going to be positive 25 over 169. I'm going to solve for x because I'm trying to find the value of x. So I subtract 25 over 169. 1 is really just 169 over 169. So 169 over 169 minus 25 over 169 is 144 over 169. And then I have to take the square root of that because I have x squared right now. And I'm trying to solve for x. So x is the square root of 144 over 169, which is just plus or minus 12 over 13. You can use a calculator to help you with these fractions, and then at the end you can just change that decimal back to a fraction, and that would give you the answer. Okay, number 9, I tried to help you out by drawing a picture for this. So when drawn in standard position, an angle theta has a terminal ray that lies in the second quadrant. So I drew a triangle in the second quadrant. The sine is equal to 9 over 41. So sine, here's my angle theta. Sine is opposite, so I put the 9 over here on this part of the triangle over hypotenuse, so I labeled this 41. And then I just did the Pythagorean theorem to solve for this missing side right here. So x squared plus 9 squared equals 41 squared. X squared plus 81 equals 1,681. I subtract 81 because I'm solving for x. X squared equals 1,600. Then I take the square root of 1,600, and x is 40. So now I add the 40 to my triangle right here, to my picture. And I want to find the cosine of theta. Cosine is adjacent over hypotenuse, so it's 40 over 41. I do have to remember, though, that I'm in the second quadrant, and cosine is negative in the second quadrant, so my answer is negative 40 over 41. And 10, I also have a picture for. Circle O has a radius of 2, so I put the 2 right here. An angle with a measure of 45 degrees is in standard position. The terminal side of the angle intersects the circle at point C. What are the coordinates of C? So basically, I have this right triangle right here, and I know that the hypotenuse is 2 because they told me it had a radius of 2. These sides are both the same, x and x, because the angle's 45. So this is a 45, 45, 90 triangle. So I did x squared plus x squared equals 2 squared. X squared plus x squared is 2x squared equals 4. I divide by 2 and x squared equals 2. So x equals the square root of 2. So that's how I got this side being radical 2 and this side being radical 2. And then I want to know the coordinates of point C right here. So point C is x comma y. It's radical 2 comma radical 2. All right. Otherwise, another way I can do this is I'm basically, if I want to find the coordinates of a point C, x, y, x is cosine, so cosine of 45. Y is sine of 45. But I had a radius of 2, so I need to multiply this by 2. So 2 times radical 2 over 2 is radical 2, and 2 times radical 2 over 2 is radical 2. So that's another way to do that. Okay, and those were the answers for lesson 4.